Hello everyone, welcome to Developers and Coders Club YouTube channel. Now we are going to discuss the third problem of today's weekly contest, that is shortest uncommon substring in an array. So let's look into the problem statement. You are given an array R of size n and consisting of non-empty strings, and we need to find an array answer of size n such that answer of I is the shortest substring of AR of I that does not occur as a substring in any other string in array. So if multiple such substrings exist, answer of I should be the lexicographically smallest, and if no such substring exists, answer of I should be an empty string. And we need to return the array answer. So yeah, let's look into the example here. So we are given an array. This is the array of strings, and we need to find out this answer array. So first of all, if we look into CAB, now in the CAB we need to find a substring, which is the shortest substring. So to generate all the substrings, first let's try over every substring. Like for example, first let's try over C. So is C is there in any of the other strings in the array? Yes, C is there here, and A is also there here, and B is also there here. So we cannot find out a substring of length 1 here. So now let's move to length 2. CA is a substring of length 2. So CA is not there in any of these strings or any of these substrings. And if we look into AB is also not there in any of the substrings of these strings. So CA and AB can be our answers. So out of CA and AB, we need to find the lexicographically smallest string. That is, see, if answer A should be lexicographically smallest. So out of AB and CA, the lexicographically smallest is AB. So that's why we have chosen our answer as AB. Now, if we look into AD, first let's try for the length of one substrings. That is A. A is already there here, and D is also there here. So there doesn't exist any substring of length 1. So if we look for length 2, AD. AD is also there here. So AD cannot be our answer. So now we cannot form any substring from this string which does not exist in other string. So that is why we return an empty string. And in this, similarly, BAD, the string of length 1 cannot exist because since it is there over here, B, A, and D. And if we look for BA, yeah, BA is not in any of the other strings. So we return BA. AD is there here. So we do not return AD, and BA is the answer. And coming to C, C is the only substring for this string, and C is present over here. So that is why we return a empty substring. So similarly for this example also, if we check like ABC is present over here, so we cannot form any substring. And similarly BCD is also a substring of this string, so we cannot form any substring. And out of ABCD, the largest substring ABC is also present and BCD is also present over here. So the smallest uncommon substring is ABCD. So so the simple solution of this question is just implementing the brute force, because the constraints over this problem are very less, that is just 100, and the string length is just going to be less than or equal to 20. So it is possible, it get accepted if we just implement the brute force. So yeah, in this code I have just made a function to check whether the particular substring present over is present in all the as a substring for in all the strings of ARR. That is, I've just iterated through ARR, and we should also make sure that the I is not equal to index, and ARR of I, if we find out that the substring exists, then return true, otherwise we just return false. And coming to the solution, first we form an answer vector by iterating through every element of ARR, and here we generate all the substrings through these two for loops. that is for length, and also the index of the string. So here we generate all the substrings, and yeah, now the substring we are naming it as sub. And if we ever found out that the substring is already there in the string, that is like, for example, here AD, if we consider AD is already there in this array, so it returns true, right? So if that happens, we are just continuing. That is, we go and search for other string, other large string or other string. So if it is already present as a substring, then we continue. Otherwise, we just store that substring into an answer string, and we just maintain this boolean value to check whether the next coming upcoming answer might be less lexicographically smallest than this. So that's why we are just maintaining this found, and we are also checking whether, if like the, for example, like this substring length is again equal to short dot length, then, and that it is lexicographically smallest, then we again store the lexicographically smallest string into this, and we just make sure that the found is returning true. And after this, we just push back our shortest substring into the answer, and at last we return the answer. So this is just an implementation of the question, and thank you.